vast, immeasurable depths, stretching billions, even trillions of light years in every direction. The more we explore, the more we discover larger structures, and we will never know what lies beyond the boundaries of the observable universe. The largest structure discovered to date is a Great Wall. They were found due to the unusually high density of an extreme phenomenon in the universe, gamma-ray bursts. But such a structure not only violates theory but also breaks the size limit in the universe. Scientists still have much to learn and may have missed many things. But it is certain that hidden within the boundaries of this structure is one of the greatest mysteries in the entire universe. What are gamma rays?
Gamma rays are an extremely penetrating form of electromagnetic radiation.
They are produced on Earth by natural radioactive decay, nuclear explosions, and even by lightning and storms. Carrying the highest energy of all electromagnetic waves, gamma rays can destroy living cells.
They have the shortest wavelength of all electromagnetic waves, about the size of an atomic nucleus.
In fact, they are so short that gamma rays pass through atoms as easily as meteors pass through our solar system. On a cosmic scale, gamma rays emitted from supernovae, black holes, and pulsars can wipe out entire planets and star systems. Gamma-ray bursts. Gamma-ray bursts, gamma-ray flashes, or gamma-ray bursts are the most powerful and brightest explosions in the universe. They are believed to form during the creation of black holes. Although lasting only a few brief seconds, gamma-ray flashes produce energy equivalent to the energy emitted over the Sun's entire 10 billion-year lifespan. This mysterious phenomenon was first discovered in 1967 by the U.S. Air Force's Vela satellite.
According to NASA, this reconnaissance satellite was designed to monitor secret Soviet nuclear tests.
But it accidentally detected bright gamma rays from outside the solar system. When this phenomenon occurs, it becomes the brightest gamma-ray object in the observable universe for a short time. It wasn't until 1991 that astronomers launched the Compton Gamma Ray Observatory with the Burst and Transient Source Experiment, BATSE. Since then, scientists have discovered gamma-ray flashes at a rate of almost once per day. BATSE detected gamma-ray flashes evenly distributed across the sky, indicating they occur everywhere in the universe.
It also showed there are two types of gamma-ray flashes with distinct properties.
One type lasts 2 to 30 seconds, and the other lasts less than 2 seconds. Since then, researchers have learned much about gamma-ray flashes by developing a system of rapid response satellites and ground-based observatories to observe gamma-ray flashes promptly after detection. This system provided evidence that gamma-ray flashes are in galaxies billions of light years away. And after the first gamma-ray burst, the source continues to produce delayed afterglow radiation with wavelengths in lower energy ranges. Where do gamma-ray bursts originate? The long-duration version of gamma-ray flashes was found to be associated with extremely powerful supernovae, called hypernovae. According to NASA, this phenomenon occurs when a star 5 to 10 times the mass of the Sun ends its life cycle and collapses into a black hole. Hypernovae are 100 times brighter than regular supernovae. They may be produced by rapidly rotating stars or those with exceptionally strong magnetic fields, adding energy to the burning process. However, short-duration gamma-ray flashes, accounting for about 30% of the total, remained a mystery until 2005. Mainly because they occur too quickly and are hard to follow up with observations. After its launch in 2004, NASA's Neil Gehrels Swift Observatory finally collected data to observe the delayed afterglow of gamma-ray flashes. Swift discovered that they are likely produced when two dense stellar remnants, called neutron stars, collide and form a black hole. Or when a black hole swallows a neutron star. Those bursts are so powerful they create ripples in spacetime, called gravitational waves. Currently, researchers have launched the Gravitational Wave Observatory using the LIGO interferometer, capable of detecting gravitational waves from such collisions. They hope to gather more information about the processes behind short-duration gamma-ray flashes. The bursts remain mysterious. To date,
There is so much we do not know about gamma-ray flashes.
recent observations show that all photons emitted from gamma-ray flashes have isotropic oscillations. But for some reasons, the direction of these photons changes over time.
Melvin Cole, a scientist at the University of Geneva in Switzerland,
stated after announcing a discovery in 2019 that we still do not fully understand the meaning of this.
gamma-ray bursts seem to concentrate energy into narrow beams instead of emitting uniformly in all directions.
This suggests that our satellites have missed many gamma-ray bursts. Astronomers estimate that,
Although satellites detect nearly 1 gamma-ray burst per day, there are about 500 gamma-ray bursts occurring at the same time. So far, gamma-ray bursts have only been detected in distant galaxies.
however, a gamma-ray burst occurring in our Milky Way galaxy is entirely possible. The Ordovician extinction event, one of the 5 major extinctions on the planet, occurred 450 million years ago, possibly caused by ice ages triggered by a gamma-ray burst. If a new gamma-ray burst occurred near Earth, it would wipe out the ozone layer and expose all life to deadly ultraviolet radiation. Therefore, although scientists value the opportunity to study gamma-ray bursts in the future, it is better that they do not appear in our galaxy. In observations of gamma-ray bursts in the universe, scientists unexpectedly discovered the largest structure ever known. A massive gamma-ray burst wall, the Hercules Corona Borealis Great Wall, is the largest known cosmic structure. It is a huge cluster of galaxies forming a sheet about 10 billion light-years long,
7.2 billion light-years wide, and nearly 1 billion light-years thick.
It is about 10 billion light-years away from us in the constellations Hercules and Corona Borealis. This structure was discovered in November 2013 by mapping gamma-ray bursts. Gamma-ray bursts are very rare, occurring only once in a typical galaxy every few million years. The stars causing these bursts are very large, so the material needed to form them must be very abundant. These bursts can be used to determine if there is a galaxy in that direction, or if there is a large cluster of matter there. Between 1997 and 2012, the team of American and Hungarian astronomers, led by István Kovács, John Hakila, and Jot Vasily, mapped gamma-ray bursts in the sky.
With the support of the SARS-CoV-2 Observatory and the Fermi Gamma-Ray Space Telescope,
they searched for gamma-ray bursts and measured their redshift. In the map they created, they discovered something interesting. 14 gamma-ray bursts had
very similar redshifts and were very close to each other.
This suggests a very large cluster of galaxies and matter in the area. The research team stated that measuring these bursts would reveal a giant structure, 10 billion light-years in diameter. For comparison, the Milky Way, where we live, is only about 200,000 light-years wide. And the distance from the Milky Way to the Andromeda Galaxy is only 2.5 million light-years. The huge LQG,
the largest previous structure in the universe, was only 4 billion light-years thick.
The discovery of the Hercules Corona Borealis Great Wall contradicts the theory proposed by Albert Einstein called the cosmological principle.
The cosmological principle states that the entire universe is nearly homogeneous.
Any two regions in the universe would look very similar, even if they are far apart. Assuming those regions are larger than 250 to 300 million light-years, the maximum size of structures is about 1.2 billion light-years, based on the theory, and no structure is larger. Assuming that matter is evenly distributed from the Big Bang.
However, this structure is 8 times larger than the limit, contradicting the cosmological principle.
The Hercules Corona Borealis Great Wall also contradicts theories about the evolution of the universe. This structure is 10 billion light-years away, meaning we are seeing its light from 10 billion years ago, while the universe is only 13.8 billion years old. A period of 3.8 billion years is too short for a 10 billion light-year-long structure to form. Even Istvan Hovat, the discoverer of the structure, admitted that he did not know how it had formed during that period. In fact, the authors of the study concluded that a structure could explain the clustering, but they never named it. The term Hercules Corona Borealis Rigwan was coined by Rick Vance, a Filipino teenager from Marikina on Wikipedia. To date, the existence of this structure remains a mystery to cosmologists.